Anuradha Singh has done her PhD from MNIT Bhopal. Presently, she is working as an assistant professor in Department of Basic Sciences at Nagpur. She has published in various international and national journals. She is also recipient of Dr. D.S. Kothari Postdoctoral Fellowship from UGC India. Her area of interest are numerical analysis, differential equation, and data analytics. Today, madam will talk on mathematics for data sciences. So in our session, you may have seen that we are having a two session for mathematics for data sciences. So first taken by madam and another session is given to another expert. So I request Dr. Anuradha Singh madam to continue and to start the session on mathematics for data sciences.
Okay, thank you so much for providing this opportunity, and without wasting much time, I would start. Basically, we would try to cover all the essentials required for data science, means all the statistical tools required for data analysis and data science. So first, we will start with the descriptive statistics, and then we'll move towards the measures of central tendency, and then we will try to cover. I'm not audible, sir. Let me check. Sir, is it okay now? Hello? Hello? Is it okay now?
You are audible, ma'am. Please be continued.
You are audible. Not audible. Your voice is not coming.
Okay. So whenever if you feel any difficulty in or some audio or in the slides, so please stop immediately. Okay, so first session means in this session we would start with descriptive statistics, all the statistical tools required for data analysis and data science, and then we will try to cover all types of distributions which are required to arrange data, because these days what is happening, you all have sufficient amount of data. So much data is available, but you need proper statistical methods to analyze your data. If you talk about the present scenario, so if someone is collecting the data of COVID-19, so in the month of March and April, there were less amount of data, but if you talk about month of October and November, so sufficient data is available country-wise, rate of mortality rate, infected rate, so but no one can predict actually for any of these, means any of the countries, that when it is going to stop or when it is going to when the curve of this COVID-19 will get flat. So we would start with this. So if you talk about the data, so the source of data, the information is very, very important. For any kind of analysis, you must have some information, basic information about that topic, but if your data is available, that data cannot do anything. You have some techniques to analyze that data. So data has its own language, like sign language. Also, if you talk about statistics cannot do miracle. You need to connect your statistic with the data, then only you will come up with some solution or with some predictions. So, okay, so statistics is a language of data, and if you see this matrix, the basic rule is garbage in and garbage out. For example, if you have chosen correct statistical tool and you have collected your data appropriately, so if you are applying this proper statistical tool on the correct data, in that case you are going to get correct decision. But if your method is correct but your data is wrong, means there is some problem with the data, in that case you are going to get the incorrect decision. Second, if you have chosen the wrong statistical tool and if your data is correct, then also you will get incorrect decision. And in last case, when data is wrong and method is also wrong, so definitely you are going to get incorrect decision. The simple rule is garbage in, garbage out, means if data is wrong, you are going to get the wrong output. For example, if you are going for collecting the data of the daily waste, whatever is the garbage means waste of particular families or of your society. So if you need to decide at which time you are going to collect that waste or collect the information. Suppose someone is going in the morning time, another one is going in the afternoon time. So definitely some of the families are just demolishing, or they are just putting it outside in the car, or that whoever is collecting that garbage, they may take it out. So the timing you have to choose in properly, and if you are going in the wrong time, so definitely your information source of data may be wrong. So you need to choose proper data, means correct data, and you need to choose the correct statistical tools. In that case only you are going to get the correct decision. Here we will talk about the analytical tools, central tendency of data, mean, median, mode, geometric mean, harmonic mean, etc. Dispersion in data, how your values or your data is, or your information is varying. Then structure of data, whether it is symmetric, skewness, kurtosis, etc., or relationship in data. Sometimes data may be correlated with each other. Sometimes they may be irrelevant data, means they are not related with each other. For example, okay, so for example, if I am giving you 10 columns, so there are 10 columns. In each column, I am storing the information of my mobile. Suppose in column number 1, I am entering the data of Facebook. In column number 2, I have stored the data of WhatsApp. In column number 2, I have stored data of YouTube. Likewise, we have stored 10 informations in 10 particular columns. Now, if I ask you which of these columns are related to each other, it is a gray patch. Okay. Got it. Got your point. Is it okay now? Is it okay now? Okay.
Madam, you can switch off your that you can have more bandwidth.
Okay, sir. So now I have stored 10 types of information in 10 columns. If someone asks you that whether column number 1 is, I have switched off my camera, sir. So I hope now this audio is clear.
Yes, now.
Okay. So if I have stored 10 types of information in 10 columns, if someone asks whether these two columns means if WhatsApp is related with, if suppose if I have stored data of WhatsApp in column number 1 and Facebook column number 2, so column number 1 will be related with column number 2, because most of the features WhatsApp or Facebook are having the common features. So in this case, column number 1 and column number 2 will be related, and the columns are not related with each other. For example, Aaj Tak, if I have explored any news channel, so Aaj Tak is not related with WhatsApp or Facebook, so there will be less relation. So in order to relationship between the data, we need to use correlation coefficient, rank correlation, intra-class correlation, or regression. If I want to find which type of relationship the variables are sharing, so in that case I need to go for regression. So these are some of the available tools in statistics, and we will be discussing all these tools in detail. Okay, so many times students come up with this question that if we have sufficient tools for plotting your data, so what is the need of the analytical methods? So sometimes it's wrong with the data. For example, if you are collecting the data of the blood pressure of 50%, let's say you have collected the data of 50 students, and by default or by mistake, if one entry, if rest of the columns or rest of the entries are supposed between 70 to 80, and one entry by mistake you have written 86. that this value is going to affect your entire calculation, because the blood pressures are in the range of 70 and 80, and one entry you have wrongly entered as 186. So this number will be known as outlier. Outlier means sometimes it may be a problem with the machine, or sometimes it may be problem with the entry. You have taken it 86, but in the Excel sheet you have entered it as 186. So if you are having such types of outliers in your data set, so with help of plotting you may identify it. You are plotting box, if you are using box plot, so in box plot you may see that outlier very easily, but you need to sometimes you need to analyze it. Means you need to calculate your mean value in check, or you need to check the variation, what is the standard the variation in the data, and then you can cross verify your result whether whatever you are getting in the plot is it correct analytically or not. Means the mean values you can plot and mean value you can calculate, and then you can cross verify your values. Approaches work together and are inseparable. So you must have techniques and you must use the graphicals also in order to plot your data. So this is again is a collection of methods which help you to describe, summarize, interpret, and analyze data. So all these things are theory. So I'm just skipping it. Okay. So now very important terminology in statistics is sample and observation. So whenever these terms occur, population, sample and observation. So population means the numbers on which you want to perform some calculation. For example, if you want to check how the literacy rate of your society, so you need to consider suppose 10,000 people or 20,000 people. So these 10,000 or 20,000 population. Now, but sometimes it may be difficult to perform these surveys on all these 10,000 or 20,000 people. So what we do is we draw some samples. For example, selecting 50% from each building, from building number 1, building number 2 and building number 3. So these 50% will be our samples. Now, whatever we want to calculate on the large population, we would perform these calculation on these small samples, and whatever result we are getting from these samples, we would apply these results on the large population. So samples will be drawn from the population, and observation, the units on which we measure data such as persons, car, animals or plants. So if you are performing any surveys on persons or car or animals or plants, will be your observation. Population means number of people, and samples means drawn from the population for your analysis. Next, we talk about variables, because variables you need to identify, you need to declare in advance. For example, if we are considering data of any cancer hospital, various types of entries in your data set. One column may be of age, second column may be of gender, third column may be of height, fourth column may be of types of cancer, another column may be of types of cancer, level of chemotherapy, and the body temperature. So now all these columns will have different types of data. Means if you are types of time of chemotherapy, so that column may be in hours or seconds or in ml, something like that. But if you talk about the age or height, the types of cancer, so the entries these columns will be different. So if you are considering such type of data, you need to declare different columns as different types of variables. Some of the columns may be continuous, some of the columns may be nominal, some may be ordinal. So we have to decide these variables in advance, and then we need to choose our tools based on these types of variables. For example, if we have discrete variables, so we will definitely go for all the techniques which are capable of handling discrete types of variable, and if your data set is continuous, for example, age is a continuous variable. So you need to choose the methods which are capable of solving or handling continuous types of data. Again, this is a definition. For example, if you set X, capital X, in which you have stored these information of gender. So the entries may be either male or female. So again, X is a mapping relationship which maps this set to this set I. Basically, you are connecting two sets with a formula is known as variable. So again, this is mathematical equation. You just need to understand that variables you may store different values in a single variable if you are declaring it array type. So no need to declare a separate variable. Suppose if 5,000 entries in one column, you are declaring that column as xi, and now you are varying I from 1 to 50, or let's say 500. So one variable will be x1, second variable will be x2, likewise last variable will be x50 or x500. So in this manner you can define your variables. Okay, so now we have classified our variables into different categories. And first is qualitative variables. Qualitative variables means which takes values x cannot be ordered in logical or natural. For example, the color of the eye. So you cannot order it that blue eyes are better or black eyes are better or gray eyes are better. So this is a variable, but you cannot order it in some logical way. The name of a political party is also an example of qualitative variables. The type of transport used to travel to work is another example of qualitative variables. Next is quantitative variable. So in this type of variable represent measurable quantities. It can be ordered or natural way. For example, size of shoes. If someone is wearing a shoe size of 10, someone is wearing of 9. So I can order it. The 10 is bigger than 9. Price of houses, Mr. Studied, and weight of a person. So these are some of the examples of qualitative and quantitative variables. So qualitative means which cannot be ordered in a logical way. Quantitative means be ordered in some logical or natural way. Next is discrete variables. So any variable takes finite number of values. So this will be known as discrete variables. For example, if we are considering marks of the students, suppose one student has got 24 and another student 25. So there may be only one entry between these two numbers, and that entry may be 24.5. I cannot give the marks in this entire range. That means I cannot 0.3, 22.1, 22.2, 22.3. These types of marks I cannot give. So this will be an example of discrete variable because it is taking finite variable. Another example, can you give any example of discrete types of variable? All qualitative variables are discrete, such as colors of eyes, region of the country. Variables can be discrete, shoe size, number of semesters. So all these variables will take finite number. Male and female, very good, very good. Male and female, another example of discrete types of variable. So you need to keep this variable in your mind as if it takes finite values, then it will be discrete. Takes all the values between two numbers, then it will be continuous. Next is continuous, which can take an infinite number of values, the length of an antelope, distance between units. Also, the weight of students. If we talk about weight, some student may be of 86.1, 86.6.3, 86.4, 86.5, 6, 7, 8, 9, 10, 11, 12. In this manner, I can consider all these values between two weights, 85 or 86. So it will take all the values between two. So it is an example of continuous variable. So we have classified, again you need to remember qualitative, which cannot be ordered, quantitative, which can be ordered, discrete, which takes finite value, and continuous, which takes infinite values. Thing which we need to do with the data set, you need to arrange your data set with the help of these variables. You need to define it, that column number 1 is of discrete type, column number 1 is continuous type, column number 3 is qualitative, column number 4 is quantitative. You need to separate your columns of the given data set, and then we will choose the appropriate strategy to handle those columns. Next we have scales. So first scale is nominal scale. In nominal scales, the values of a nominal variable cannot be ordered. For example, gender of a person, male or female, you cannot order it, means one is superior, another one is inferior. Status of an application, pending, not pending. So these types of variables cannot be ordered under nominal scale. Next is ordinal scale. Values can be ordered. However, the difference between these values cannot be interpreted in a meaningful way. For example, education, non-primary, education, secondary education, university degree. You can differentiate it, but sometimes it is difficult to order it. Means if you are going for some interview and if the minimum criteria is MTech, is also eligible, PhD is also eligible, or higher, or any postdoc candidate is also eligible. So in that case, it would be difficult to order it because the minimum criteria, all are satisfying the minimum criteria. Continuous scale, the values of a continuous variables can be ordered. Furthermore, the difference between these values can be interpreted in a meaningful way. For example, the height of a person refers to a variable. So you can order it, say 175 feet, 5.1, 5.2. So you can order it, the height of these persons. So nominal, which cannot be ordered, and continuous scale means which can be ordered. Okay. So we have group data. So what are the need of group data? If political parties in election with a low number of vectors are often summarized in a new category, other parties. So sometimes we need to collect group data. Can you give any real life example of data where we are handling such type of data? If you talk about the interest rate, suppose that the sum assured of an insurance company, so they use this group data. For example, in the age group of 35 to 40, or people in the age of 40 to 45. So they decide different sum assured or different for this type of group. So people are in the age group of 35 to 40 will have maximum sum assured, whereas will be lesser as compared to people are in the age group of 40 to 45. So in such type of situation, we need to use group data. In this diagram, you may understand that all types of these variables are connected with each other. That nominal may be qualitative. Yeah, pay scale for each category. Yeah, very good, very good. Is also an example of group data. Correct, very good. Must mean. Now, nominal may be qualitative, and then qualitative may be discrete. Ordinal, quantitative, and quantitative may be continuous. So again, these simple, this graph is there to show that all these types of variables are connected with each other. Okay, next is the method of data collection. Data collection, there may be various ways of collecting your data. You may collect your data from survey, you may collect your data from some experiment, or you may collect your data from the observation. So first we start with survey. For example, you might be observing that these days people, NMC people are coming in your house. They are just checking your blood pressure, your temperature. They are noting it down and they are going back. That means they are performing surveys. This how many people are there, what are their average age group, what are their average temperature on the basis of these surveys. So sometimes you need to perform a survey, sometimes you need to perform some experiment. For example, if you want to collect this COVID, you want to collect some data on the virus, then you need to perform some experiment. And if you are collecting that immunity data, so you need to take blood samples of the persons who have infected with COVID and who are not infected with COVID. You need to perform some experiment and then you are coming with some result that the antibodies, or the immunity factors, if any particular protein is supporting your immunity, so you need to perform different experiment. Observational data means you may observe routinely without designing a survey or conducting an experiment. Okay, suppose if you want to collect the data of your society, for let's say, or for online classes. So what would be your first step if you want to collect such type of data? If you want to collect the data of online teaching methods, what will be your first step? You will design some questionnaire. Yeah, correct. You will create Google Forms. You need to design some questionnaire because it might not means it may be possible that not everyone is using or familiar with the internet. So you need to go in with some questionnaire in offline mode also. So you will design some questionnaire, then you will ask means are you happy with this, are you having good do you have good internet connection, how is your children responding during online classes, are they performing, are they learning something? So you will design such questionnaire, and then you will go for the survey. Experiment is very easy, means in lab, means if you that let's say talk about the vaccine. So if you want to collect some information about the vaccine, then you need to perform some experiment. You need some experimental data and observational data. Sometimes you observe it. For example, if you impact of social media, observational data, you may observe your children, you may observe your colleagues, you may observe your neighborhoods, and then you can create such type of data with help of observation. So these are some of the techniques of collecting data. Next is primary and secondary data. Primary and secondary data, and think about it. What is the difference between primary and secondary data, and which one is more accurate? Okay, now I have given you 1 minute. No. My audio is not lost. I've just muted myself. Primary and secondary data means primary data which you are collecting yourself, and secondary means the primary is more accurate actually. Secondary data, if you are taking your data from some consultancy or from some another website, so that will be our secondary data. So primary will be accurate because that data you are collecting yourself are more consistent, and secondary maybe means little bit more, maybe lesser than, there may be a chances of some discrepancy in the secondary data because that you are taking from another source or from second source. Okay, next is creating a data set. For example, if you have performed some surveys, you have a piece of information, or you just give me 1 second. So if you have some information, you always try to save your data in form of a matrix. They secondary. Secondary means you are taking from another source. You are not present while collecting your data. That will be secondary. For example, if you are taking the data of Johns Hopkins University from their websites, that is also secondary. Because other persons are surveying and they are just writing it. Sometimes, for example, if I want to collect a data and I have made a team of 10 people, that those 10 people are going there and they are writing something. That will be secondary because you were not there. If someone is making a mistake, so that value is going to affect your entire data set. I have given you this example of blood pressure, that if the blood pressure of your society, and suppose all the data are between 70 to 80 or 18 to 90, but one entry is some, or two entries around 150 or 180. So those two values may affect your data. So after collecting the data, next is to arrange our data. So we always try to arrange our data in form of a matrix, means in form of rows and columns. To give the labels to these columns so that others can also understand. For example, if you are collecting the data and you are not labeling those columns, in column number 1, it's a age, column number 2 height, column number 3 weight, column number 5 gender. If you are not labeling it, then again it would be difficult for you to identify. In this manner, suppose you have collected 50,000 entries and if you labeled it, so it would be difficult for anyone to understand it. You need to again check each and every entry, or you need to check types of variables. So we always collect data and we arrange data in matrix or rows or column, and we always labels our rows and columns so that it can be understood by anyone. Next is frequency measures and graphical representation of data. For example, you have collected some information and now you want to plot it. For example, if there are 10 people in a supermarket queue, each of them is either coded as F if the male and M if the person is male. Now collected data may look like M, F, M, F, M, 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 F, M, M. So now there are two categories, M and F, means M for male, F for female. So we use A1 to refer the male category and A2 to refer the female category. So now we are in these two columns as variable A1 and A2. And there are and 3 females. If you will count it, number of M are 7 and number of females are, means F are 3. In A1 we have 7 entries and in A2 we have 3 entries. So the number of observation in the particular category is called the absolute frequency. Number of this line, number of observations in a particular category is called the absolute frequency. So absolute frequency of male is 7 and absolute frequency of female is 3. So in this manner, we need to identify the absolute frequencies. So N1 7 and N2 3, and if you add it 7. Sorry. You please mute yourself. N1 plus N2 is equal to, because 10 and 3 females, the total number will be 10. Now, if you want to calculate the relative frequencies of A1 and A2, absolute frequency means number of observation. But if you want to calculate the relative frequencies, in that case, you need to calculate the relative frequencies by using this formula N1 divided by N and N2 divided by N. 10 divided by 7, there is a typo. Divided by 7, you will get 0.7. And sorry, N1 was 7 divided by 10. 7 divided by 10 will become 0.7 and 3 divided by 10 will become 0.3. Relative frequencies for males and females will be 0.7 and 0.3 respectively. So basically means now depends on your requirement. Depends whether you need absolute frequency or you need relative frequency or you need which type of mean, absolute mean, this geometric mean or harmonic mean. So depends on your requirement, what you want to do with the data. Accordingly, you need to choose frequencies, mean, skewness, that tools you need to decide depends on your requirement. Next is absolute frequency formula is same, Nj upon N, where Nj means absolute frequency and in denominator we have N means total number of observations. And the sum of all the relative frequencies lies between 0 and 1. What is 1? Summation of j is equal to 1 to n, f j to 1 to n, f j is equal to 1. Can you please justify it why we are getting all the frequencies is equal to 1?
So the total of relative frequencies will always be equal to 1.
Yeah. Okay, next we have grouped continuous. Group continuous data. Normalization is also correct. Also it related with probability. If you see it, sum of all. Good. Consider the following n is equal to 20 results of the driving license examination. So these are the marks of 20 candidates in the written examinations. Now, one way if you want to calculate the frequency, you will check each entry. Suppose those who are in the range of 10 to 20, those who are in the range of 30 to 40, 40 to 50. So for the small set, it is easy to do that. But if you have 5,000 entries or 10,000 entries, in that case, you need to check each and every entry, or you need to write a code that for example, same as we do for bubble shorting or selection short. You choose one element and you compare that element with rest of the elements. And if that element is the greatest, you put that element in the top of the list. In this manner, we arrange our list in ascending or descending order. So instead of doing so, we would make different groups, class intervals 0 to 20, 21 to 40, 41 likewise. And now this data can be represented in this form 0 to 20, 21 to 40, 41 to 60, 61 to 80. So we have divided entire data different class intervals. So now absolute frequency 0 to 20. If you see the previous slide, how many entries are there between 0 to 20? Only one, that is 16. Rest of the entries are outside that range. So absolute frequency will be 1. Similarly, in the range of 21 to 40, we have 3 entries, and last same 81 to 100 we have entries. Now, if you want to calculate relative frequency formula is Nj upon N. So 1 by 20, F2 will be 3 by 20, F3 will be 3 by 20, and last will be 4 by 20. Sum of all Nj's will be 20, and sum of all Fj will equal to 1. So in this manner, depends again, I am repeating this line, that depends set. Whether you want to check each entries or whether you want to create different ranges, and then you want to calculate your absolute frequency or relative frequency. So if you have large amount of always better to divide your data in different class intervals and to calculate absolute frequencies. For example, if you are writing the code for this, what F5 is 4 by 20, na? Yeah. That will be 4 by 20. That is 4 by 20. 4 by 20 is correct. Okay. Now, if you are writing a code for this, for these entries, so what will be your code? You will, what will be your code? What will be your logic for this matrix? If you want to check, if loop is okay. Logic. What you would write under if loop? If else. Yeah, range you need to write, and you need to use nested if else. Isn't it? If this, else if, else if. Am I right? Okay. So now next is empirical cumulative else if ladder. Yes. Empirical distribution function. Now you let me know first what is the significance of calculating empirical cumulative distribution function is actually same as cumulative distribution function. So in short we write ECDF. What is the significance of calculating it? CDF, cumulative distribution function. In 9th-10th standard, I think we have cumulative frequency. At that time, we used to call it as cumulative frequency because we were not aware of this term, distribution. Cumulative distribution function. Closer to 1, but if you want to find, covers the percentile, it's partially true. If we want to find the frequencies, till certain points, or sum of probabilities till certain points, then we need to go for cumulative, because in cumulative what we do, we write first number, then we add that number with the second entry of the, then we add third entry of the column with the, so we add previous numbers basically. So if you want to check the sum of probabilities or sum of frequencies till certain points or till certain, that case we need to go for this. Calculation of median. No, median we don't use it. Don't use it. Cumulative frequencies, cumulative distribution function. So basically you take it as a sum of frequencies. So it gives an idea of relative frequencies up to a certain point. Basically, it's sum, nothing but more than that. So how many people scored up to 60 points in previous example? How many people up to 60 points in previous example? So it can be calculated by adding the number of people in the class interval 0 to 20, 21 to 40, 41 to 60, 20 plus 1, 60, which corresponds to n1 plus n2 plus n is equal to 7. This is the cumulative. Inclusive brackets. All these means, So you take ECDF as a sum of frequencies. Again, this is formula of this ECDF, an empirical cumulative distribution function. So suppose if I want to calculate ECDF for ordinal variables. So this is the table, satisfaction level J is equal to 1, J is equal to 2, 3, 4, 5. And we have values of NJ in row number 1, FJ in row number 2, and capital FJ. So write CDF with capital letters, capital F. So FJ we have calculated with 4 by 200 means relative frequency, 16 by 200, 90 by 200, 7 and 20 by 200. And now we want to calculate capital F means sum of frequencies. So first entry will be 4 by 200. 4 plus 16 means 20 by 200, 90 plus 80, 110 by 200, 70 plus this 180, and last will be 200 by 200 because final value of f will be cannot exceed than 1. So in this manner, we can calculate ECDF. Okay, so now I'm summarizing what we have discussed here. We have discussed types of variables and then different types of means different ways of data, survey, experiment, and then observational data. Types of data means primary and secondary. Then we have discussed absolute frequency, relative frequency, and this ECDF means cumulative distribution function. So whenever you have some data, if it is supervised, if it is in arranged form, you can go for different types of distribution. Otherwise, you need to arrange your data. So for arrange data, you need to fix your types of variables. You need to decide the types of variable with each column, and then you go for this further statistical analysis. Means you want to calculate mean, you want to calculate frequency, or you need to go for variation, skewness, other types of measures of central tendency. Okay, now these are some of the plots of ECDF and a range. So these plots we'll see in art. Okay, let me come. Okay, next we are discussing measures of central tendency. Actually, I'm trying to distribute functions. So all these things are basic. So much material is available. Means so many books are available. So if you have anything, you may ask. Otherwise, we would try to come on distribution first, because distribution is the preliminary stage of arranging your data. So measures of central tendency, again I'm skipping this slide. Okay, now let's take this example. Baiju is a farmer. He grows food grains in his land in a village called Balapur in Buxar district of Bihar. The village consists of 50 small farmers. Baiju has one acre. You are interested in knowing the economic condition of small farmers of Balapur. You want to compare the economic condition of Baiju in Balapur village. Are you able to capture anything from this information? Do you believe that the given information is sufficient for any kind of analysis or information? Why? Which type of information you need? Because they have not mentioned that quality of the soil. Numerical values are missing, correct? So types of crops they have not mentioned. Okay, if you have such type of information, and if someone asks to calculate or come up with some conclusion, so it would be difficult for us to calculate it, because so much information is missing in this data. Want to calculate anything, so if you want to evaluate the size of his whole landing by comparing the size of land holding of other farmers of Balapur, to calculate above average in ordinary sense, means we need to calculate arithmetic mean, size of above the half the farmers own, and the most of the farm own, labor charges, correct. We need all these informations. So if suppose if you are having those information, what you will do? First, you would try mean, in ordinary, what is the average crop of that area, isn't it? What is the median? What is the, and then mode, what above what most of the farmers own. Yeah, means average. So you need these measures of central tendency if you want to predict, to draw some conclusions for the given information. So you need to calculate arithmetic mean, you need to check median, you need to check mode. Okay. order to evaluate Byju's relative economic condition, we will have to summarize the whole set of data of land holding of the farmers. This can be done by central tendency, which summarizes, means you will have a single value in your hand. If it is arithmetic mean, again you will have a single value. If it is mean, again you will have a single value. If it is mode, again you will have a single values. And then values you may predict something. So the central of measured tendency consists of arithmetic mean, median, and mode, but depends on your data. Every time it is not beneficial to calculate arithmetic mean. Again, depends on your data set. Sometimes we need to go for harmonic mean, sometimes we need to go for geometric mean. So that you need to understand, that you need to analyze that which type of average or mean will be helpful for your data set. Okay, so mean means it's very simple, summation of x upon n, sum of all data values upon number of data values. Okay, any one of you please let me know what is the physical significance of mean? Why every time we are calculating mean? Why we are not starting with median or mode or something else? You always start your calculation with mean. Why it is so important? Average value, that we understand it. Everyone understand what is average value, but what is the need of average value? That I want to know.
Estimate of the population.
For example, if I am providing you the marks of 100 students of my subject, let's say, I have given you marks of 100 students, and now I'm asking you who has performed better, who are good students, who are bad students. How would you identify it? You need to find the average marks, or what was the level of question paper. For example, if I'm asking you that, suppose if the question paper was so difficult, if suppose question paper was so difficult, or I have evaluated the paper very strictly, so definitely if I have done the strict evaluation, in that case average marks will be what side. To understand the data distribution is absolutely correct. So we should have the average value just for the second step. Know that the average marks of the students are 56, suppose. So you may have this idea that either the paper was difficult, that everyone has, means because the average marks is 56 or suppose 34, the teacher has not evaluated it properly, isn't it? You may draw two conclusions. Suppose if the average marks of the students in my subjects are 34, so what would be your conclusion? 34 out of 100, the average marks of the students is 34 or 36, just passing. That most of the students have got around 34 or 36, and are you getting it? Most of the students are weak. So there may be many reasons, whether prepared well, whether classification purpose correct, or question paper was so difficult, or the teacher has not evaluated. So you may have these 4-5 reasons if the average is below 30 or below 40. So that is why I'm trying to say that most of the information are you may get from the average value. For example, if the average height, suppose if the average height of the class is 6 feet, then what would be your conclusion? In your class, suppose in your family, 6. Most of the students are tall. Okay, so we need type of conclusion from the data set. That's why, all are tall. So these types of information we may draw with help of average value. That's why we always go for average value first, and then we apply rest of the statistical measures of central tendency. So if arithmetic mean for ungrouped data, arithmetic mean for grouped data. So these days no one is calculating it manually because so many tools and the programming softwares are available. You just need to use this command EAN and then you get the value within a fraction of second. But you need to understand that arithmetic mean for ungrouped data and arithmetic mean for grouped data. So there are two ways of calculating arithmetic. Now, direct method, you add all the values and divide it by total number of observation. For example, 40 plus 50 plus 55 plus 78 plus 58, and you divide it by 5. So you will get average marks of economics text. Second is assumed mean method. If you try to remember in class 9th or 10th, we used to apply this method. Assumed means where if your data is very large, suppose are in 3 digits or 4 digits, in that case, instead of how central tendency is accurate prediction. I'm not getting your point. So second, with help of assume means, so I'm not going into that because again we are not calculating it manually. There are methods are already written in the compiler or in the library for the software, and we just need to use those commands. Next is for continuous series. For example, you may sometimes you group your data. You create some class intervals for your, as we have done for the previous question. So sometimes, exclusive class interval 0 to 10, 10 to 20, and so on. Inclusive 0 to 9, 10 to 19, and of unequal class interval 0 to 20, 20 to 50, and so on. In all cases, calculation of arithmetic mean is done in a similar manner. You just need to find observation lying in these class intervals. Means you need to write the frequencies. And you need to take the midpoint. If it is equal call intervals, you need to take the midpoint, x into f. The summation x into f divided by summation of f. So these are some of the ways of calculating arithmetic mean. The properties of arithmetic mean, the sum of all the observation about arithmetic mean is always equal to 0. For example, x minus x bar is equal to 0. What is the significance of this? Summation of items about arithmetic mean is always equal to 0. Summation x minus x bar is equal to the data for it, which type of values you will get? Summation
The
x
difference of the observation from their arithmetic mean, their summation is always equal to 0.
true, but how is it possible? Because some of the entries will be on positive side and rest of the entries will be on the negative side, on the same scale. So those values will get cancelled.
Yes.
Yeah. So in this manner, we get summation of x minus x bar is equal to 0. And arithmetic mean is affected by extreme values, means any large value on either end, up or down. This is very important. If you have outliers in your data, that outliers is going to affect your arithmetic mean. So you have to be careful. If you're not plotting it, you are going for the arithmetic mean, and if you have any wrong entry in your data set, so that entry will affect your value. So you have to be careful. First, you need to identify the outliers. If there is no outlier, then you can directly go for arithmetic mean. Otherwise, you have to remove that entry. Okay. Okay, let's take some more examples of mean, and then we will come to random variables. For example, suppose someone from a holiday in Bangkok during the month of December and would like to get information about the weather when preparing for the trip. Suppose last year's maximum temperature during the day for December 31 are as follows. Okay, so what will be your conclusion if you have this data set? prediction or what would be your decision on the basis of these entries?
Temperature is quite nominal, then we can go for the trip.
Okay, so how did you calculated it?
Because of the normal temperature is on and average is 30 ma'am. So 30 degrees temperature is a nominal, so they can plan for a trip in the month of December, according to the last year.
Average temperature, है ना?
Yeah.
And on the basis of that average value, you are predicting that the which type of clothes they should carry, है ना?
Exactly, ma'am.
Yeah. Okay, so you are observing or looking at the individual values gives us a feeling about the temperature, है ना? One can experience in background, but it doesn't give the complete summary. So in that case, you have to calculate the average, and the average value is 6.48. So now this value may help you to decide which type of clothes, है ना, you should choose for your holiday. Next is, है ना, another measures of central tendency. Suppose students scoring 40% in an examination will be happy with the result if the average scores of the class is 25%, and if the average class score is 90%, then the student may not feel happy if he got 70% right. What is your decision, or what is your observation? I'm repeating, a student scoring 40% in an examination will be happy with the result. He doesn't get average marks of his class also. So
the students in the classroom have not done
so if he is, if the average score is higher, then not happy, isn't it? If the average score is lesser, then in that case he will be happy. So again, average value is important in this case. Okay, so arithmetic mean for group data, we have already discussed absolute frequency, relative frequency, class intervals. So in case of group data, we use this formula, summation f into x summation f. So again, from the previous slide, instead of looking the individual entry, if we are getting the average or arithmetic mean, that mean is 26.48 degrees Celsius. Now this will help you to decide, to plan your trip or for the choice of clothes. So actually we use this command weather, and then we create this data set to 20 to 24, and the similar manner you can create in Python. So you need to calculate mean weather because the vector or the column data set is weather. So you will get the output in the next line, that is 26.48. If we have this class interval less than 20, so we have absolute frequency and relative frequency. 0 plus 12 by 31 into 22.5, the center point of this, center point of this, center point of this, and then this. In this manner, we can calculate arithmetic mean. R command for calculating weighted arithmetic mean, weighted dot mean. Next is median, another measures of central middle value of rank order data, value that separates the higher half of a data set from the lower half, can be found by arranging all values from lowest to highest and determining the middle. Sometimes you need to calculate median for some decision making. And for example, if the data set is 6912651, so first arrange this data from lowest to highest, and now you may check is 5. If we have even numbers, in that case, first we need to arrange, the first process is same. You need to arrange your data set from lowest to highest, and then you need to add 2 middle entries and divide it by 2. So you will get the median for even number of entries. Or in R, we use this command median of weather. So you will get the output, a single command. And mode means most frequent measurement. For example, the previous slide of Byju's, if we want to check what other farmers what other farmers are cropping in their land. So that crop we need to calculate mode. If they are going with suppose some rice, particular type of rice, so the mode for that crop will be higher. So 12, 11, 15, 12, 12, 11, 14, 17 and 12. So when you write it, number of cars sold and the frequency, the highest frequency is of 12. Mode will be 12. If no number is repeated in the data set, there is no mode. Next
If there is a tie, what should be taken, ma'am? Excuse
Sorry?
me. If there is a tie case, that means if you have more than one number having the same number of frequency, then how to take the decision?
There will be 2 modes then.
So we have to take one value, or we have to take how? We only interested in one value only, right? When we are dealing with central tendency, so we are interested in one value only. So if in case of more than one mode values, so how to take the decision? Which one to be chosen?
No, there will be tie, no? Please go to the advanced level. Okay, I'm coming
take
to that.
For example 10.
Suppose 11 is also 4.
Yeah, same number of 11 is also 4. Then what has to be considered? Which number to be considered?
Will be 11 and 12 both, because there is a tie, no?
In case of median, we are taking average. So in case of mode,
same, no? Then you add it. If you 4 plus 4 divided by 2, again you will get 4.
No, I'm not. Okay. So instead of
4 plus
okay,
4.
we have to consider 11 or we have to consider 2.
It will be 4, no?
Here, mode indicates the value which has highest frequency rather than the frequency
Mode is
count.
12. Mode
So
is
if you have
12. Mode is not 4. Mode is 12.
Sorry.
That's what.
But the frequency is same, no?
So if 11 and 12 has the same frequency, so how to resolve this tie? So we have to go with randomly chosen or
you need to decide whether you want to go with one.
Video on ಮಾಡಿದ್ಯಾ?
someone is laughing. Can you please
Participant, please mute yourself. Otherwise, it will be others. I cannot mute because I don't have that control. Only host can mute actually. Okay, well, I'll come back to this point. I'll come back to you. Just I'll come back to this point. Okay, so this mode. Okay, I'll back. The type of data determines which measures. Types of data determines which measures should be used. So quantitative and qualitative means numerical. We need to, for numerical value, we have to use 2 types of data set: discrete and continuous, means mean or median. And if we have qualitative data, means categorical, we have to choose 2 scales, nominal and ordinal. In that case, we will be calculating mode. Now, if we are plotting our data, for example, if you are plotting and if you are getting this type of graphs, what would be your conclusion? If you are getting something like this, if you are getting this middle one, and if you are getting something like this, what would be your conclusion about the data set? Okay, if you are suppose if you have plotted this for the marks of student or for the grade of student, so what would be your conclusion from graph number 1?
Is it a dynamic data set, ma'am?
Yeah, Nana, if you are plotting the curve of the grades of students, so good performance. So either students have prepared very well or the question paper was very easy, isn't it? There may be two conclusions. Suppose, the students have performed very well or the question paper may be very easy or the checking was or the evaluation was lenient. And if you are getting this type of curve, that means most of the students are in this average grades, BB or BC. That means question paper was moderate and 50 students means 50% questions were there that everyone can solve. 20% or 25% questions were there, only 25% can solve, and 25% were on the easier side so that everyone can solve. That means basically overall conclusion is the curve is normal and the paper or students were moderate. Second is if you are getting something like this, students are on the higher side. Suppose if they are difficult paper proof, correct, poor performance. So we can conclude, suppose their students are on the now they are the lower side. Suppose most of the students are getting DD or EE grade. So either they have not performed well or the question paper was so difficult or that the teacher has strictly. Are you getting it? Okay, and if the positively skewed right distribution, so in this case, mode will be higher than median and then mode your curve is skewed on the right. And if your curve is skewed on the negative side, in that case, you will have mean will be than median and this time mode will be on this negative side. And sorry. I think I missed. Okay. And if you distributed normally, in this case, mean is equal to median is equal to mode, means the curve is normally distributed. In this case, all three values will be equal. Okay. If you have, okay, now if your data values are far away, so these will be outliers. We have already this point outlier. Suppose most of the entries are in the range of 20 and 35 and here we have this outlier, so we can identify it by plotting it and you need to remove this outlier. And outliers have extreme effect on the mean. For example, if you are considering 5 6 4 7 6 19 and if you have 5 6 4 7 6, If you have outlier in your data, your will be will get affected by this outlier. And outliers do not have extreme effect on the median. So if you are calculating median and if you have outliers in your data set, so that outlier won't affect your data set or don't affect your median. We have partition value. So if you want to arrange your data in some ascending or descending order of magnitudes, then you have to divide your data set in. So the 4 equal parts are called quartile, 10 equal parts are called decile, 100 equal parts are called percentile. So sometimes you need to classify your data with help of this quantile. So in QQ plots, so with help of QQ plots, you may decide your quartiles, decile and percentiles. So QQ plots are there in R, for this scale. To setting 3, you may use different types of settings of QQ plot. So many options are available. So you may use different options. Next we have mean. So the geometric mean plays an important role in fields where we are interested in products of observations, such as when we percentage changes in quantities. So if you are using where that you need to use the product of the observation, so you should always go for geometric mean. For example, if someone wants to deposit money, says €1 in a bank, the bank advisor proposes a 5-year savings plans with the following plan for interest 1%, 0.5, 2.53. And now he would like to calculate the average growth factor and average growth rate for the invested money. The concept of the geometric mean can be used. So if you want to your interest rate with that amount, so in that case you need to go for geometric mean. And similarly, harmonic mean is also there. So harmonic mean is typically used whenever different xi contribute a mean with a different weight. So if you have weight element in your data set, so you need to go for harmonic mean. So again, some example is given for harmonic mean. Next we have measures. So if you want to check the variability of your data set, how values are varying in that data set, then you need to go for measures of dispersion. You need to go for variance, skewness, kurtosis. For example, these students, Christine, Andreas, and Sandro arrive at different times in the class to attend their lectures. Time in the class. Okay. So there are 3 students, and in this table, their arrival timing in the class is given. Then what would be your conclusion? Are 2 students same, Christine and Andres? Are they? If you are calculating mean value, no. So what would be your conclusion if you have this type of data set? So in this case, average value is not going to help you, because if you decide your decision on the basis of average, so the average will be same, is 0, 0. But the nature of the student is different. Christine is never going in the class, whereas Andres is going, but sometimes he is 10 minutes earlier or 10 minutes late. So average value is same, but the students are not same. If you have this type of situation, you need to go for other measures, or you need to check the variability. So the summary of this session is the measures of central tendency data with a single value which can represent the entire data. Arithmetic mean is defined as the sum of the values of all observations divided by the number of observation, and the sum of deviation from the arithmetic mean is always equal to 0. Sometimes it's important to assign weights to the different items, and sometimes we need to calculate median and mode instead of calculating mean, as we have seen the previous example in that class है ना timings of the students. In that case average is not going to help you है ना. In order to divide our data set into 4 equal parts, 25%, 75%. So those who are using R, they must be knowing the importance of box plot. In box plot you get all the 6 values about the data set: median, mode, lower value, upper value, and 25% and 75%. If you are plotting box plot for any data set, so you will get all the information in single command. Mode is the value which occurs most frequently. Okay, now I'm coming to the advanced level. Okay, to arrange your data or to check the nature of the data, you need to find or you need to use distribution functions in order to arrange your data. So here we will be discussing random variables, probability distribution, probability mass function, expected value, and different types of distribution. So random variable means, what do you understand by random variable? What is the significance of random variable? So random variable is nothing but a variable, means what you want to do with the data. For example, if you are tossing a coin, what is your aim? See a head or a tail. So capital X may be either head or tail. Yeah. I'll share with everyone. So random variable is a mapping from X to R. Means it is providing a numeric value to your data. For example, again, if I am rolling a dice and if I am looking for this, looking for the values greater than, let's say greater than 4. So my X values will be 5 or 6. I may get only 2 numbers who are greater than 4 if I am rolling a dice. So I may get 1, 2, 3, 6, but I am interested in values with greater than 4. So I'll get 2 values. So either I may get 0 or I may get 1 or I may get 2, isn't it? There are only 2 values ना. Either I may get 0, मतलब हमको हो सकता है हमको वैल्यू क्या मिले, छोटा मिले 4 से. I may get value, any value which is less than 4. So in that case, X value will be 0 because my X is greater than 4. So either I may get 0 or I may get 5 or I may get 6. 0 means your value may be less than 4. So then in that case, I will write 0. X as 0 means your condition has not fulfilled. You have not achieved your aim. About experiment, but basically it's a aim, what you want to do with the data, what is your aim, what you exactly. For example, outcomes means if you are tossing a coin twice, random variables may be HH means 2, HT means 1, because random variable is number of heads that appears. In this case, number of heads will be 1, and in this case, I'm not getting any head. So random variable will be 0. Are you getting it? Random variables, it provides a numerical value to each outcome of an experiment. Next is type of random variable: discrete and continuous. Discrete which takes finite values, continuous that takes values or all values between 2 values. So the number of blank calls during 11 to 1 p.m. there may be infinite blank calls, or it may take all the calls, all the values between 11 to 1. That is why it is continuous. And the number of heads tossing a coin is discrete. Next is type of probability distribution. Discrete, so we have 2 types of variables, discrete and continuous. So we have different distributions associated with these variables. So if we have means binomial and Poisson are for discrete type of probability distribution, capable of handling discrete variables, whereas normal distribution is a continuous. So it is capable of handling continuous variables. So if we have discrete variables, we will go for normal distribution and Poisson distribution. If we have normal distribution, so definitely we will go for, if we have continuous variable, we will go for normal distribution. One more thing, Poisson is a limit binomial, and normal is also a limiting case of binomial. Means all binomial only. So we can derive formula with help of binomial, and we can also derive formula of normal distribution with help of binomial distribution. Gaussian is different. Here we are discussing it. Gaussian is there, exponential is there, uniformly distributed, many types of distribution, but we are discussing only three. Binomial, there are different types of assumptions with the distributions. Again, depends on your data set. So probability function, if x is discrete, we write p is equal to fx is called probability of mass function. And if it is continuous, then we write it as integration of fx dx. So for x is discrete, we will be using summation sign for probability mass function. And if it is of continuous, we will be using integration sign. So this integration of fx dx is called probability density function, and y is equal to fx is called the probability curve. This p capital X is equal to small x is equal to fx is called probability mass function. So these are two properties of probability distribution. Discrete, for discrete we write it as pxi. So all the values of pxi lie between 0 and 1, and the sum of all probabilities is equal to 1. So these are two properties of probability distribution, and sometimes we need to use these properties in order to calculate if some constant are occurring in your data set. So those constant may be evaluated with help of properties. Okay. Example, an experiment randomly selected 2 people from group of 5 men and 4 women. A random variable capital X is the number of women selected. Find the probability distribution function of X. Yeah. Normal is Gaussian. Gaussian, normal, both are same. Uniform distribution is different. Exponential distribution is different. Gaussian, normal, both are same. Binomial are for discrete. But some of the questions of binomial distribution can be solved by Poisson and vice versa, because depends again, because it's just in the variation of n. For binomial, n is finite. For Poisson, n is infinite. And p and q are very small as compared to n. So, but some of the questions of Poisson can be solved by binomial. Okay, what is the conclusion? An experiment randomly selected 2 people from group of 5 men and 4 women. So how many total? 5 and 4 means 9. Random variable capital X is the number selected. So how many women we can select? I may select 0, I may select 1, I may select 2, I may select 3, I may select 4. I may select 4. A random variable X is the number selected. So I may select 0 women, I may select 1 woman, select 2 women, 3 women, all 4 women I may select. Binomial distribution is okay, but here I am just asking. So women, if probability both are men, if I am not selecting any women, so that will be 5C2. 5C2 because all there are 5 men, so I may select all 2 from 9C2 because 5 plus 4, 9. So 9C2 will be 5 by 14. If I am selecting 1 woman, so from out of 5 men, in that case, I need to select 1 man and from out of 4. 5C1 into 4. Why we are multiplying it? Let me know why I am not adding it. Probability of women. Why we are multiplying it simply? No, that I understand. 5 by 14 or 5 by something. Because they are independent. Correct. Very good. Because they are independent. Occurring of one is not affecting. If I have drawn from here, so I can 1 from this 4. Next is if I am selecting 2 women, so 4C2 upon 9C2. So why I am not going for 3? Why I have not written P3? Because we are allowed to select only 2 people. I cannot go more than that. They have allowed me to select only 2. So least probability that there is no women, then there may be 1 woman or there may be 2 women. So P0, P1 and P2 I may calculate in this. There is no binomial, there is no Poisson. We are simply calculating probabilities. No, we are not using any distribution function. The distribution function. What is the advantage of using distribution function? If you are not using in this manner, you can calculate. But suppose if the data is very large, if someone asking you to select 50% out of 1000, what you will do? Please mute yourself, otherwise. So now if I'm not using any distribution function, so in that case I have to go with this method that I will calculate 0, 1, 2, 3, 5, 6 up to 500, and then when I will arrange entire probability. And now I am arranging my data in this form: x is equal to 0, x is equal to 2, and the corresponding probability. This type of arrangement is called probability distribution. If someone asks you what is probability distribution, that means are arranging with help of random variables, and the associated probability will be is known probability distribution. This is exactly probability distribution, because here you can see no women probability is this, 1 women probability is this, 2 is probability is this. Now expected value. So this is the formula. What is the physical significance of expected value? Suppose a player is playing a game. A player A is playing a game. Sometimes he is winning, sometimes he is losing. Correct? And now he wants to calculate the expected chance of winning the game. Expected chance of winning the game. So what he need to do? He is playing the game. He is playing a game. Sometimes he is winning, sometimes he is losing. Now he want to calculate average chance of winning the game. In that case, he need to calculate all the winning combinations. Suppose he is winning first game, then he is winning 5th game, then he is winning 9th and 50th game or 100th game. In this manner, game is continuing. So he need to choose all the values where, or all the chances where he is winning, and then he will divide it by the total number of games played. Then he will get the expected average number of winning the game. So in this case, he need to go for expected value. So expected value is nothing but is same as average value. A tray of electronic component contains 9 good components and 3 defective components. If 2 components are selected at random, what is the expected number of defective? Again, simple. Array of electronics contains 9 good and 3. So total number of items are 9 plus 3 means 12. And if 2 components are selected at random, what is the expected number of defective? So again, defective, 1 defective and 2 defective. And the formula is same. If there is no defective, means all are from this 9C2 into 3C0 divided by 12C2. You will get 12 by 22. If there is 1 defective, so 9C1 into 3C1 divided by 12C2. And if both are defective, 9C0 into 3C2 divided by 12C2. You will get this 1 by 22. And the expected value is 1 by 2. Okay. So if there is equal to 0 defective, so P is equal to 0 defective means all our items of fresh items will be NC2 into 3C0, because all 2 items are na. Yeah, I'll share with everyone. Don't worry, don't worry. And then 12C. Now you solve it. 9C2 means both are from fresh item into 3C0 into 12C2. You simplify it. 2 means factorial 9 upon factorial 2 into 9 into 2 means factorial 7, and then 3C0 will factorial 3 by factorial 0, factorial 3 minus 0, that is 1 upon 12C2. So factorial 12 upon factorial 2 into 12 minus 2 means 10. Now you may take out this 12, 12 outside this factorial, then 11. So that 10 will get cancelled, and 2 will cancel out this. So 12 into 11 means 6 into 11 you will get in denominator, and in numerator you will get 36 by 66. If you 6 so 6 by 11, 6 by no, you simplify it now. 9 in numerator we will get 9 into 8 divided by 2 numerator 9 into 8 divided by 2. In denominator we will have 12 into 11 divided by 2. So this into 11, 10 will get cancelled here, 2 and 2. So this 2 will get cancelled by this 2. This 2 will get cancelled by this 2, and we have 9 cross 8. 9 cross 8, 12 cross 1. 12 cross 3. Now 3 3s are 9 and 3 4s are 12. 4 1s are 1 and 8. So we will get 6 by 11. 6 by 11. 6. Oh, sorry. Have I done something wrong? Factorial 9 by factorial 2. Factorial cross 8, 7, 7 will get, we'll get 2. And here 12 cross 11 divided by 12 cross 2, 10. So 10, 10, 12, 11. 2, 2 got cancelled, 9 and 18. 6 by 11. Okay. Okay. Correct. 6 by 11 I am getting here. Similarly, we can calculate P1 and P2. Now what we, how we have calculated is EX. EX will be P0 into 0 plus P1 into 1 plus P2 into 2. This is the formula of EX. This EX. P0 into 0 into 1 and P2 into, what are you getting? You might be getting 1 by 2. If you multiply it with 0, this will become 0. Here you will get 1, 9 by 22, and here you will get 2 into 9 plus 2, 11 by 20 by 22 means 1 by 2, isn't it? The expected number of getting defective component is 1 by 2. So expected value is nothing but average value actually. Average chance defective component. Are you getting it? Okay. Now discrete probability is, now I'm into probability. What is the role of using distribution function? If I'm not using it, and every time I need to calculate the probability and then I need to go for EX. So instead of doing so, we always go for the probability distribution. Matlab inbuilt functions, probability distribution, binomial, Poisson, or normal distribution. So there are some assumptions. If any data set is satisfying these assumptions, then only I can apply binomial or this Poisson or this normal distribution. So the experiment is repeated a fixed number of times, means n is finite. Each trial has 2 possible outcomes, success and failure. The probability of success remains the same, means P is constant, trials are independent, and 4s are sufficient actually. So n is finite, There may be two outcomes, P and Q. P is constant and trials are independent. If any data set is satisfying these four properties, then I can apply binomial. Why it is known as binomial? Because and the formula probability mass function is NCX P to the power X Q to the power N minus X, where P is the probability of success and Q is the probability of failure, and this is the formula. This is well proved formula, no need to prove it. You simply type Bernoulli or binomial and you will get this formula. Now why it is called? Because if you find the sum of, if you put summation sign here, sum of probabilities NCX P to the power X Q to the power X, then you will get this binomial expansion. You use the binomial expansion and the sum of all the probabilities will be equal to 1. Hence, it is called binomial distribution because it uses binomial expansion. Formula is NCX P to the power X Q to the power N minus X. Now, mean for binomial distribution is N into P, variance is N into P into Q, and the standard deviation is root over NPQ. What is the difference between variance and standard deviation? Okay, now let's take this example. An expert, he can distinguish between a cup of instant coffee and a cup of pre-collator coffee 75% of the time. It is agreed that his claim will be accepted if he correctly identifies 5 of 6 cups, find his chances of having the claim. First accepted, second rejected. Suppose this question comes and you know all types of distribution. What you will do? There is nowhere is mentioned that whether you should go for binomial, Poisson or normal. You have to decide your own. Then how would you identify? Yeah. Standard deviation, how much? And he can distinguish between a cup of instant coffee and a cup of pre-collator coffee 75% of the time. Now you need to check his claim. It is agreed that his claim will be accepted. Identifies at least 5 of the 6 clubs, find his chance of having the claim. Now, how would you decide that which type of distribution will be best fit on this question? First, you need to decide the types of variable, whether it is discrete or continuous. You have only 2 options. If it is continuous, you have 3 options. Binomial, correct. N is finite, and there are P will be by 100 because it is a cup of pre-collated coffee 75% of the time. So Q will be 1 minus 3 by 4 means Q is 1 by 4. You have 2 outcomes P and Q. Now X is, you need to random variable every time. S number of times correct distinct. So Px is equal to 6Cx, P to the power X, Q to the power 6 minus X, and X is equal to 1, 2, 3, 4, 5, 6. So you these values of X, but what is in your favor? You will accept his claim if he correctly identifies at least 5 of the 6 cups. At least 5 of the 6 cups means he can identify cups. So greater and equal to 5 will be equal to P5 plus P6. You need to add 2 values. Greater and equal to 5, you need to add 2 values, P5 plus P6. You need to calculate P X is greater and equal to. So that can be calculated by writing P5 plus P6. Correct. P5 plus P6 will give you one. So I'll share this PPT and all the PPTs that we have discussed here, and you may go through it, and if you have any doubts you may ask me directly. I'll be sharing my email ID with you all. Presently we are working some projects of data science, so if you guys are interested that we can collaborate. Poisson, it's almost similar to binomial, but we have to take care of n value, and the formula is different. Actually, I was planning to take all these, but okay, I need to skip it. I will try to come to Poisson distribution. Formula is e to the power minus lambda to the power x by x, where lambda is a positive real number which is greater than 0, and it is 0. Again, some questions based on Poisson distributions, so you may practice. When p is infinitely small, means p tends to p tends to 0, n tends to infinity. If there is a huge difference, p tends to 0 and n tends to infinity. Again, continuous distribution, normal distribution, and the formula is this, and we have already discussed the properties of PDF. Let me come to this. Okay. Questions. Okay. Have table. You have measures of central tendency, and you have some distribution. So suppose if I am sharing one data set, so first supervised, if it is arranged form, you need to arrange, means no need to arrange it. If it is in unsupervised form, first you need to arrange it with help of the variables, with help of the types of this distribution function. Suppose you have arranged, then you can calculate mean, median, and mode. And sometimes you need to find the correlation and the regression. Actually, there is a second, tomorrow I think you have second session where you will be knowing means how to use correlation and regression. These are means advanced statistical tools for data analytics. Today we have discussed only the basics, fundamentals tools for data analytics. Mean, median, mode, probability distribution. After probability distribution, here we have discussed only for one variable, but in real life you have to deal with probability distribution of several variables. In that case, you will have x and y. For example, you are considering height and weight both. So in that case, you need to use joint probability distribution. So formulas are different for joint probability distribution. Then you have expected value, and then you have moment generating function. And after moment generating function, we come to correlation and regression. After correlation and regression, you have sampling. After sampling, you have testing of hypothesis. And last point is estimation. So these are the steps for performing data analytics. Measures central of this measures of central tendency, probability distribution, then correlation regression, then sampling, then this testing of hypothesis, and last point is estimation. Of the questions I could not answer because I was focusing here and I have missed some of the chat, some of the queries written in the chat box. So sharing my email ID with you all, and if you have any question, I'll be, or I will share the Google Drive link, and where you can find all these materials. You can download it. Okay, so I'll be sharing my that Google Drive link, and with Jiten Tembuna sir, and you guys can find all these materials on that Google Drive.
Participants, I request if you are having any queries, you can raise at this point so that madam is available. It will help. She will.
Jitendra sir, will we be getting the recording of this talk?
Yes, you will be getting. So,
okay.
For that, you don't have to bother. Recording, PPTs shared with you.
Okay, fine. Thank you, sir.
So I give thanks to Anuradha for the wonderful talk regarding the mathematics required for data science. She emphasizes on how we can distinguish data, classify, and how we can understand the data, how to understand the role of outlier and all other things. So I really appreciate the efforts of madam. And also I believe that it is benefited to all of you so that you can understand more regarding the related mathematics, because that is of computer science, even that is more related in data science as well. So you will try to explore it. You are having any doubts, any queries, you can directly contact to madam. You can mail to me, and you can associate it with Nagpur for any other reason or any collaboration or any research work. So I give thanks to everyone. I give thanks to madam also. So at this point, if you are not having any queries, so we can close this session.
Okay, thank you so much, sir.
Thanks, ma'am.